So today we're going to talk about the factor theorem and the remainder theorem. We're in 4.3. Our learning goals for today are to be able to use the remainder theorem to evaluate polynomial equations and functions. And second, we're going to use the factor theorem to determine if a polynomial is a factor of another polynomial. And this is going to relate really closely to the dividing and synthetic division that we've used before. All right? So first we're going to talk about the remainder theorem, and I'm just going to kind of show you how it works, and I want you to think about what you notice about the following problems. So I have the function f of x equals 2x cubed minus 3x squared plus x minus 7 right here, and part A says find f of 3. Well, find f of 3 simply means that I'm going to plug 3 into that function and figure out what the output value is. So f of 3 equals 2 times 3 to the third minus 3 times 3 squared plus 3 minus 7. And I've replaced all the x values with 3's, and now we're going to do some calculations. You can use a calculator, but I'll go ahead and do it all out by hand. So 3 to the third is 27, minus 3 times 3 squared. 3 squared is 9, so do that, plus 3 minus 7. And 2 times 27, that's 54, minus 3 times 9 is 27, plus 3 minus 7. And now moving from left to right, f of 3 equals 54 minus 27 is 27, plus 3 minus 7. Well, 27 plus 3 is 30, minus 7 is 23. So I get f of 3 equals 23. All right, so now let's go up to this other problem up here, and if I try and scroll over, okay, so now on the second part B, what I'm going to do is I'm going to divide 2x cubed minus 3x squared plus x minus 7 by the factor x minus 3, or by that polynomial function. So I'm going to go ahead and use synthetic division. Remember, synthetic division, I think about what is the 0 for x minus 3? What is the value that makes that equal to 0? And that's positive 3. And then I'm going to set up my synthetic division bracket. And then I'm going to take all the coefficients of my polynomial and write them out. So 2, negative 3, 1, and negative 7. And now I'm going to start my synthetic division. Step 1 says, hey, always bring down that first factor. And then I'm going to multiply. 3 times 2, so the outside number multiplied by my bottom number, 3 times 2 is 6, right there. And now I'm going to add down. So negative 3 plus 6 is 3. Multiply. The 3 on the outside times the 3 on the bottom is 9. Add down. 10. 1 plus 9 is 10. And then multiply. 3 times 10 is 30. And now add down, and I get my remainder of 23. So when I divide those functions, 2x cubed minus 3x squared plus x minus 7 divided by x minus 3, what do I get? Well, I get this, I really get 2x squared plus 3x plus 10, remainder 23. And now what we're really thinking about is, what do we notice between these two problems, part A in part B. So I want you to think about that for a second and then come back and try and answer that. Hopefully what you see is pretty obvious. All right, so I hope that everybody was able to see that f of 3 is the same as the remainder as the division problem. And that's basically what the remainder theorem means. If I divide some polynomial function by a linear factor, the remainder is the same as if I would have evaluated by the 0. So if I wanted to evaluate f of 5 for this function f of x, all I need to do is the division problem, and I can use synthetic or long division right here. So I break down the 2. 5 times 2 is 10. I get 7. 5 times 7 is 35. I get 36. 5 times 36 is pretty big. 36 times 5 is 30. And 30 and 15, so 180. So that's 180. And then when I add down, I get 177. Well, f of 5 is equal to 177. And that's how we use the remainder theorem. Alright, so now we're going to use the remainder theorem to evaluate the following problem. I have f of x equals x cubed plus x squared minus 5x minus 6. I'll give you some time to write that down. If you need to pause. For part C, example C, we're going to evaluate at x equals 2. So I'm going to set up my synthetic division bracket. I'm going to go 1, 1, negative 5, and negative 6. Those are the coefficients of my polynomial function. And then I'm going to start my synthetic division. I bring down the 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. Add down, I get 1. 2 times 1 is 0. And when I add those down, I get negative 6, which would lead me to believe that f of 2 equals negative 6. Okay? And if you don't believe me, you can plug negative 6 into your calculator, or plug negative 2, into x, all the x values, and use a calculator to evaluate that one. But the nice thing is that synthetic division is kind of quick, and we can do these problems fairly quick. So here we go. I've got negative 2 on the outside for part D. And I'm going to write down my coefficients again. And now we'll start our synthetic division. So 1, negative 2, negative 1, positive 2, negative 3, positive 6, and I get a remainder of 0. So f of negative 2 equals 0. And if we think about what that means that my height is 0 on this function where I plug in negative 2. So essentially, this is an x-intercept. So I have an x-intercept at negative 2, 0 because of getting a remainder of 0, which is very useful and that will come up a lot. We'll be using that type of problem a lot in the future. Okay? All right. I think that's it for examples using the remainder theorem. All right, I think this is a great time in your notes for you to go ahead and give me a summary of what we've done so far. We've got the remainder theorem. We've just done a couple problems. I've showed you how it works and how it's used. Give me a couple sentences or a little summary about how the remainder theorem works and what it is used for. All right?